All right, welcome back to Intermediate Algebra. We are going to talk about solving systems and equations today by the substitution method. All right, so let me go ahead and share the screen so we can get started doing some work here. And here we go. Okay. And usually chapters, problems are divided into sections where they tell you to use one method or the other. In reality, I'm not going to insist that use either method, but they usually go with substitution because that's a good place to start. So we'll start with that. Okay. So one of the things just to remind you of, okay, this is going to be a previous video. There are three things that can happen with two-dimensional lines. Okay. You could get a line pair that does something like this. Okay. And they cross once, so there is one solution. Now this could be, right, this could be a 0, 0, they could cross in the origin, so 0 is a number, so don't forget that. They could cross at some arbitrary fraction, they could cross anywhere, okay? So they're just going to cross at a point x, y, a, b, okay? You might get, right, two lines that are parallel, but then there's a straight, and they'll never meet. This is what they call an inconsistent system. They're never equal. They're never going to be equal. You're not going to get a solution. Okay, because we had two lines that were parallel. Okay. Strangely enough, you can get two parallel lines that are actually the same problem. Okay, you can get the same equation, just written a little bit differently. So what do you mean by that? Well, this is what the picture looks like. I'll try to get right on top of it. Okay, and these are the same line, and now they don't look like it. But you can get something like, a 3x plus 2y is equal to 6. And the blue line could have the equation of 1/2 x plus 1/3 y is equal to 1. And they're going to pretend that you can't tell the difference, that you have to solve this. And honestly, I'm often taken by surprise. I'm like, oh, all I did was divide this whole equation by 6, right? 2 over 6 would be 1/3, 3 over 6 would be 1/2, 6 over 6 would be 1. So they're really the same line. It's just that they're disguised to look like they aren't. Okay. So they'll try to do this, and this is an infinite number of solutions. Okay, usually you're going to write this in set builder notation. You're going to say something like x, y, such that y is equal to, how about we do 3 minus 2/3 x or something. And all I did was like say, well, 3x plus 2y is equal to 6. 2y is equal to 6 minus 3x, and then how about we change that? So we'll say y is equal to 6 over 2 minus 3 over 2x. So we're going to change this. So I anticipated wrong. So this is 3/2 x. Okay. And go with that as our solution space. Okay. So you can pick numbers, put them in for x, generate y values, and generate as many as you'd ever like. But that's what they mean by infinite number of solutions. And we're going to walk this like not the sky's the limit. They're constrained. Okay, but this is called a consistent system. It does have a solution. Consistent system, but dependent. Y depends on what x happens to be. Okay, so this one, the first one rather, it's consistent. Okay, and if you're in my class, I don't really ask you for vocabulary words about, is this consistent? But perhaps if you're in a different class, you might want to know that. Okay, inconsistent system, no solution, and then consistent but dependent. This is independent, that's dependent. Okay. So those are the choices that we have. Okay. So let's see here. I'm going to pick one that tends to look like a substitution problem, and I'll point out why it looks like a substitution problem. So this is a 2y plus x is equal to 9. Underneath of it is going to be x equals, and we'll have 3y minus 3. The reason why this is like kind of screaming at you, you should use substitution, is because you have a single mode variable here. Okay, if we had an x minus 3y is equal to 3 minus 3, this would still strike me as a substitution problem because it requires one step, and we have x is equal to 3y minus 3. Okay, so if you have like a one-step kind of a substitution thing you can do, that's pretty much what's suggesting to you substitution might be the easier way. Okay, but when we get to elimination and you like that one more, then be my guest, use that one instead. Okay, but elimination we would have to work around a little bit. Okay, but not that big of a deal. Okay, so there we go. So I'm just going to equate this as 1, I'm going to equate this as 2, and all I'm going to do is I'm going to take equation 2 and I'm going to push it into equation 1. So we have 2y plus x. Well, what was x? X was 3y minus 3 is equal to 9. Okay, and I know the books tend to go over this really fast. Sometimes they miss this step and the student is left with what happened. Okay, so I try to make it really clear, like we pushed equation 2 into equation 1, I make a little box, I put the equation into the box so you can see what happened. Okay, so we have 2y plus 3y minus 3 is equal to 9. Okay, and then we're just going to go ahead and solve this regularly. So we're going to add 3 to both sides, add 3 to both sides. 3 plus 2, right? That's 5y is equal to, 9 plus 3 is 12. And we get y is equal to 12 over 5. Okay, double checking. Okay, so now we can go back and solve for x. So we can say, well, x, recall, x was equal to 3y minus 3. Recall. Okay, equation 2. So all we're going to do is we're going to say, well, x is equal to 3. What the heck was y? Y was 12 over 5, right? That's the y minus 3. So what we're going to do here, right, just multiplying fractions. So x is equal to 3 times 12 is 36. 1 times 5 is 5. Minus, I'm going to need a common denominator here. So I'm going to say that 3 is really 3 times 5 is 15 fifths. Okay. And then we'll just go ahead and do this arithmetic. I know that 30 minus 15 is 15, so 36, right? We have to add 6 to this, so we should get 21 fifths. Okay, and if you don't believe me, that's good, you shouldn't. Okay, so we're going to say 36 divided by 5. 5 is not a bad thing to divide by because you always get like a 0.2, 0.4, 0.6, 0.8 kind of a decimal. Okay, minus 15 divided by 5. I should have just said minus 3, right? And now what we're going to do is we're going to say math, and we're going to hit this first number here and say to fraction, enter 21 fifths. Okay. So why would I ever write that? But it's because math features like fractions, and you might have to type your answer in a fraction. Okay. So there we go. We have 12 fifths, 21. Oh, sorry, that's x. 21 fifths and 12 fifths for my XY pair. That's my solution. We're set. Okay, let me do 2 more here. See if we can't knock this one out for us. All right. How about we try, this is an m minus 2n equals 16. Actually, we'll do 2 more after this too. And a 4m okay, plus n, okay, equals 1. Okay, how do you want to go? So there's two options to do substitution. We could say m is equal to 16 plus 2n, just added 2n to both sides. I could also say this is n is equal to 1 minus 4m. I want to avoid fractions. I want to avoid hard arithmetic, so I generally won't pick this 2 because I'll be left with a 1/2 n m here, and I won't pick 4m is equal to 1 minus m all divided by 4. It's correct. It's just uglier. It's a little bit harder to work with. So if I can keep these with just ones in the front, that's my preference. You don't always get to have that preference, but that's kind of what you're hinting at. And it's completely up to you. Pick whichever one you please. Okay, I'm going to pick this one simply because it looks like the numbers are a little smaller. Okay, so this was from equation 2. This was from equation 1. We're going to push equation 2 into equation 1. So here we have m minus 2n. What the heck was n? N was 1 minus 4m, okay, is equal to 16. All right, so we have to distribute, so we're going to get m minus 2, right, plus 2 times 4 is going to be 8m. Why plus is because we have a minus here, we have a minus here, so that's 2 of them, okay, and then we all have equal to 16. Okay, so 8m plus 1m is 9m. We're going to add 2 to both sides. Okay, so we have 9m equals 18, and then divide both sides by 9. So we have 9m because we're 9 times m here. That's what that means, right? Divided by m, divided by 9 rather, is equal to 18 divided by 9. And like a very nice math book, good math book. Okay, we get a nice integer answer, so there we are. Okay, now we have to go around and get n. It's up to you how you want to do this. What I'm going to do is I'm going to take it back to equation 1 here. So we're going to say n is equal to, right, 1 minus 4m. 1 minus 4, what was m? M was 2. So we're going to get 1 minus 2 times 4 is 8. 1 minus 8 would be minus 7. So n is minus 7, m is 2. So we have our 2 minus 7 is our solution, and we should be set. Okay, and then I'm sorry, I'm going to draw this out twice more. Okay, so let's pick another problem. Fortunately, they were the answers in this one, so I can pick the one I want real easy. So we're going to pick a t, okay, minus 4. Okay, t minus 4, oh, t equals, sorry, t equals, okay, t equals 4 minus 2s. Okay, my s's always look like 5s, so that's a cursive or a script s. Okay, that's s. Okay, so that's what we have. Okay, thank you, Sister Mary Agony, for teaching me good handwriting. Okay, I'm kidding, she tolerated me. Okay, so we have t plus 2s is equal to 6. So this is kind of set up very nicely, right? As a substitution, we have t is equal to 4 minus 2s. So we have equation 1, we have equation 2. So let's push equation 1 into equation 2. Okay, so we have t. What the heck is t? T is 4 minus 2s. Okay, is equal to 4. Okay, I'm sorry, plus. We just have plus. Here we go. There we go. So t plus, and then here we have plus 2s equals 6. Okay, so we have 4 here. We have minus 2, really, s plus 2s is equal to 6. These cancel, and then we get this 4 is equal to 6. Okay, and we know that that's complete nonsense. 4 is not 6. Okay, so this is a no solution. So when you see this kind of nonsense, you have to realize that that sometimes is by design, and the solution, the problem was set up to be a lie, and that you're not wrong. The problem was written to mess with you. Okay, so definitely go back and double check your arithmetic. Okay. On the other hand, like if you get something like this, don't be like, I must have done something wrong. No, it's entirely possible the problem was written down so you can get a solution. Okay, so that does happen. They will do this to you. Okay. Conversely, let's see if I can find one that's the opposite way so you can see what that looks like. Yeah, that'll work. Okay. So we'll have a 4x, okay, minus a 2y equals 6. And we have a 2x minus 3 equaling y. Okay, so they wrote it backwards, but this is still y equals some stuff. So what I'm going to do is I'm going to take this equation 2, I'm going to push it into equation 1. So we're going to get a 4x minus 2y. What the heck is y? Y is 2x minus 3, and that is equal to 6. So let's distribute. So we've got 4x minus 4x, okay. 2 times 3 is going to be negative, no, it's going to be positive 6. So let's change this, erase. 2 times 3 is 6, plus 6 equals 6. So we get x minus 4x, delightful, and 6 equals 6. Well, yeah, no kidding. So this is an example of when you get an infinite solution. So again, go back, check your arithmetic, make sure it's working. But this is not, like, sometimes you do get this if you substitute, like if I substitute equation 1 into equation 1, or equation 2 back into equation 2, you're going to get this. Okay, so you can't take equation 2 and push it back into equation 2. You have to use the other equation. So don't get lost on where you are in the problem. Okay, you've picked one equation, you push it into the other one. Okay, don't push it back into itself, because then you will get this all the time. That's not always the right answer. Okay, but you see this, you're like, okay, it's always true. 6 is always equal to 6. So what we're going to do is we're going to say, well, here we go. Here's my solution set. We have x, y pairs such that y is equal to 2x minus 3. You could have written it down this way too, that's fine. But that's an example of an infinite solution, because whatever you pick for x, we're going to generate a y, and we're going to get a whole bunch of pairs. But this is as far as you need to go. All right. So there's our solution set. That's what we're going to do. And that's what infinite solutions look like. Okay, this is what no solution looks like. You could also write that or that, right? That's empty set. Since it was just Valentine's Day, we have this. You could write the words no solution. You cannot write that. Okay, you can't put the empty set inside of the brackets. That means something else. So since it was just Valentine's Day, like, let's pretend you forgot. We're now, you don't have a boyfriend or a girlfriend anymore because you forgot. That says something about your relationship, okay? But if you decided that you were going to give your paramour a present, but you put nothing in the present, like, that says something completely different about your relationship. Forgetting to get the gift, getting the gift, putting nothing in it, those are two different things. Okay, so don't confuse, like, hey, this is something like that. It's not, it's different. Okay, so just realize that you can't combine them. It's one or the other, not both. Okay, but that is how you do a substitution problem. I think we are good for this problem, or for this set, and make an example video on that. I'll see you in the next one. All right, thank you.